So I guess what I really want to spend today doing primarily is just making sure that there aren't any clarification questions on the shapes hierarchy, just to be sure that we're on the right track on that. And I don't know if confusing anything next is worthwhile. I'll talk about, I think I'll save the stream IO for next week, next chapter, primarily because I haven't really reviewed exactly what I want to do there. So I have a little bit of homework to do myself before I talk about Project 10. So maybe this is a short day, I don't know. But the shapes class hierarchy, one thing that as I was working with the student, realized that like in Java, and you deal with hierarchy of inheritance, the private variables that you want to pass down need to be labeled as protected. All right, so please be sure, and I made a mistake last week when I was indicating the private variables of 0.1, 0.2, 0.3, 0.4. Right, they obviously need to be inherited down the hierarchy. So switch that keyword from private to protected, and you will save some efforts there. Rather than, because otherwise your solution would be to redefine them separately, and then you'll discover that they're disconnected.
The default is protected, right? If you don't label it.
I don't know that.
It is.
Is that what it says?
Like 90%. Yeah, because I don't think I had any problem if I didn't label it.
So if you didn't label anything, so that must be why I never came up before. I was trying to think. I don't remember this issue being a problem. So that's what I've introduced is, putting in the private. Yeah. So protected is the default in a class. Yeah. I knew that it was at least private. I didn't realize that it was protected. But so I learned something. There is a parallel structure. Whether it's worth mentioning or not, but I'll mention it. There's a similar kind of structure in C, the parent of C++, the originator of the language, called a struct. struct is a structure in which you would also declare variables. And I do know that unless you specify private, protected, or public, the default there is public. Okay, so for a struct, the elements are public. For a class, by default, the elements, unless otherwise directed, apparently are protected, when that makes sense.
Oh wait, the private. Wait.
Oh, so now you're changing your.
Wait, no, I said private originally, didn't I?
No, you said you were helping to agree that it was protected.
Oh no, it's private. 90% sure it's private.
90% sure it's private. All right. Well, regardless then, you should designate them as protected because you do want the inheritance to go down you do want those instance variables to be passed down. So I think it's good practice to explicitly specify what's public, what's protected, what's private, and not go with the default. And when you're defining classes, I think that's good. That's good practice. Excuse me. What else? Yeah.
So this is the points in the quad that you're talking about?
Yes. When you declare the 4 points in the quad and you want the trapezoid to have the 4 points, you've got to make them protected so that they're available as if you declared them within. Please don't redeclare them. Don't redeclare them. Then they will be disconnected. You shouldn't.
using the point. But so I didn't have any problems. I had actually declared them as private, and I didn't have any problems.
All right. Well, we ran into a case where we switched it to public, protected, and then things started to work because otherwise we weren't seeing them. So I'm not sure.
Yeah, I don't know what the difference is.
I don't know. And that's sort of what's kind of at my a little bit of point of confusion because I'm not remembering this being as an issue before. So, but actually protected makes most sense. Yeah, it's probably has something to do with the fact that you include the H file. So by including, if you include like the quad.h all the way down, then of course you would have it. And that may be what a lot of people were doing. Right? It's a little bit of a challenge to kind of minimize the code and have it all cascade, as you work your way down the hierarchy, so that you minimize what you need for quad, and then you minimize out of quad for the trapezoid, and then you minimize for the parallelogram what you inherit from trapezoid, and so on. We get a little sloppy in some ways, and that is why you put that # if ndef, and then you give a name, and then # define and give the name, and then have that end if at the bottom of your H file. That is a protection to guarantee that you are not re-including an H file more than once. And in this case, this is where you can get sloppy. You can include the H file numerous times, and that if ndef command actually protects you from getting all sorts of multiple defined errors. Right? So that's what's going on with that. So if you were curious as to why the if ndef statement at the very beginning and then the define, right? So if ndef means if not defined. If that symbol is not defined, then you define it. Okay? And then, of course, the rest of the code is included. Anywhere else, if that symbol is defined, then that if ndef command is false, and none of the inclusion will take place the second time or the third time or the fourth time. That's what's going on with ndef, if ndef. What else? Yeah?
So I actually just realized I don't store the lengths or the heights in anything in your variables. Is there, do you want us to? Or
You should, just for consistency, because you do pass it on. It's sort of an abstract idea that you have supplied it in the construction so that it helps you build the points. So by rights, that's information, and would make sense to create them as and store them as instance variables. So your constructor, right? In your constructor, for instance, when you are going from parallelogram to rectangle, right? So you create your rectangle constructor, right? So in a rectangle, you're going to pass in point p1 and an integer length and an integer height, right? And you're inheriting that from parallelogram, right? So you want to pass P1 as your first point because parallelogram wants 2 points and a length, right? So point 1 is passed create a second point that would be, I have to draw a picture. So if this is P1, we have to generate P2, which would be P1's X, get X, and P1's get Y plus the height. All right. So then you would pass in also the length. All right. So that's your constructor, your super constructor call. Then what you should do is your height variable is set. All right. So you have a trivial assignment statement that would guarantee that you are now saving the height as your instance variable. So yeah, you should do that. There's another way you could have. You could say, we don't need to keep that variable, right? Because when you print the details of a rectangle, really all you need is to print the one point and the height and the length. You would be able to calculate, you don't need to keep the length or the height because you can calculate the length as the difference between P1 and P3, in terms of X, and the height would be the difference between P1 and P2 in the Y's. So, I mean, it is a calculatable value. And when you're designing a class and deciding what should be an instance variable, in my mind, another principle would be minimize it. Keep it to the minimum amount of information you need. If there's other things you want and you can derive it and you can calculate it, then that's what you should do. Create a getter that just does the calculation. Don't save additional redundant information. The height is actually redundant now because it's embedded in the X's and Y's of the 2 points. You can calculate the height, knowing that it's a rectangle, right? And actually, the height of a parallelogram is also calculatable by the difference of the 2 points that you have to supply. So even if you wanted to, the height of the parallelogram, in which we don't supply in my design that I've given you, you could calculate one. You could have a get height. Makes sense. And the trapezoid as well. We didn't talk about the height of the trapezoid. We just simply specify the 2 points. But we needed to specify the 2 points because there's that skewed arrangement of the 2 points. It's not so clear as to where the X would be for those points. We needed those. So there's lots of ways we could have designed this. And in terms of what you ask the user to supply when constructing a particular shape. And so this, what I gave you is not the only way, but I think it's a reasonable one. But I do recognize there are some alternatives, and I wouldn't be that opposed if you decided you want to experiment with a different way. But I would still expect the principles of don't allow the user to create a shape that's not valid. That really what it comes down to is don't allow the user to create a shape or an instance of an object that would be invalid. Right? And you want to also help that by minimizing what you have to verify. Okay. If you have to do work in verifying whether that instance is valid or not, maybe you should rethink how you ask the user to supply that information. What else? Anything else?
Just so we're clear, how many files will we use?
13.
Okay.
2 for the print, or 2 for the point,
Yeah.
2 for quad, 2 for trap, 2 for parallel, 2 for rectangle, 2 for square, and 1 driver, test driver.
I was just being clear. Thank you.
Yeah. And again, that is standard class design, where you would have an H file and a CPP file for each of those classes. You could create 2 H files. I would certainly, because you use the point, I would make it separate, because it's clearly a class that you would include in other places, right? I mean, this is why you make this separation, so that these classes can be used in other contexts. So I can imagine many other applications that could use the point class. That needs to be separate. Now, the shapes, I don't know. If you're going to have a quadrilateral and a square, you might as well put everything in between. So it would be not unreasonable, if you don't mind the double negative, to have one H file that has the quad class H, the track class H, the parallel class. You could put all of those in one, because they do inherit from each other. They are clearly related. And then the CPP file could also be that one. Java requires the files to be clearly separate. Right? One class per file. C++ doesn't care. Right? So we could have gotten away with 5. Right? And I've had students do that. Okay, actually, I kind of breathe a little sigh of relief. Oh, good, I don't have to download 13, I only have to download 5. I do not look forward to grading this. I like the project, I just wish I didn't have to grade it. Because it's 13 files, and my PDF creation will not include all 13 files. I'll include a few. I generally do the point, the quad, and square. All right, just as a as what I would want to put in my review and comments, unless I spot something in the other files that I think you should know about. But I may not create a PDF with all 13 files merged in there. All right. That's a good question. How many files? Yeah, 13. So after you wade through this, the next project is a non-object oriented project. Just some input output stream IO formatting stuff. So it will give you a little bit of relief that week of the. It is next Friday, but it'll be sufficient for me to talk about it Tuesday, because it's really a minor project. I don't even think it's 10 points. I think I might make it 6 or 8. It's 6. So that says something, doesn't it? It's 40% less work than this one. It's actually less than 40%. And exceptions is also almost trivial. All right, so we'll be adding exceptions to the rational numbers, and that's only a few lines of code as well. But I would like to take some time and give you principles of exception handling. Okay, and again, that if you're clever, you can really finish. You can do that program with 10 lines of code. But you have to be sure that you catch all the appropriate exceptions. The last project is project 12 is file input output, and I'd also like to reevaluate that one. That one is a project of collecting together a lot of code and making it a lot of file operations and putting it all in one place. So it's kind of an exercise in pulling code from the book and kind of putting it together in one location. So it's not that you've got to write a lot of code. You just have to realize how to put it together and make it all work. So it's making one project that is presented in the book as four different programs. Like, but I want it as one, and a driver that allows me to choose which of the 4 programs you're running. So that's that. And then there's the reflection paper, which is a couple pages of what did you know, what's your opinion of C++? What was your experience of self-study? I usually don't fail anyone on the reflection paper or ask you to rewrite it if you give me a couple pages. Reflect any way you want that's reasonable. Okay. And then that's it. No test. How about that? That's the plus side, right? And hopefully, you know, wrapping it up before finals. So, anything I've babbled on, I keep babbling here because I've got the time, but any other questions? Otherwise, we'll just cut you loose.
Something that's not for the program coming out this Friday, but you have Unit 2 lecture, and it's out of like 100 points, like a video. Do we have to do that as well?
That's what Dan put in as the video. So he just it's put no, you don't.
Okay.
All right. So he just have you put any other videos in? You haven't.
No, they were.
Okay. All right. So, but you put the one in, and it counted as 100 points or something. So.
That's
I
right.
I thought I fixed it so that it didn't count in your grade.
I
You
can
don't-
change the module too if it.
Yeah, probably that would make more sense. That, you know, that it's just there. They don't have to do it. They'll be stupid to not. But well, I'll work with Justine to figure out how to really set that in there so that it you know, it is looked at, it is watched. But no,
So
that.
it's just something you click on and then hit continue. It's not like.
Yeah. So that's how it's going right now to plug in the videos. So, but you just focus on the 12 projects and reflection paper.